guys, Mr. Klein here. We are talking about soil. Yes, soil. Woo! Chapter 5, Lesson 2. Let's go ahead and get started. By the end of this lesson, you will be able to answer these three questions. 1, how is soil created? 2, what are soil horizons? And 3, which soil properties can be observed and measured? Now, I've mentioned it in past in the class, but essentially, before I became a teacher, one of the things I did was for about a year and a half, I worked in a soil testing lab, a construction engineering lab for a civil engineer. And basically my job was to test dirt and its suitability for construction. And actually I would go out on job sites and test the properties of dirt, soil rather, for its use in building and construction pads and stuff. So I don't want to exactly bore you with what I spent about 18, 19 months doing, but I will give you a little bit of my insights into this. So let's go ahead and let's get going. First off, let's define soil. Soil is a mixture of weathered rock, decayed organic matter, mineral fragments, water, and air. Before we go into any more detail, you might be confused by what is soil and what is sediments and what is dirt. Okay, essentially, let's ignore dirt. Dirt is essentially sediment mainly used for construction and due to its fine-grained particle size. Now, let's look at these two, sediment and soil. Sediment in the red is essentially inorganic material from weathered rock. Okay, any inorganic material from weathered rock is sediment. However, soil contains sediment and a lot more. Okay, it contains gases like nitrogen and carbon dioxide. It contains organic decomposed material from dead organisms, and also it contains water and occasionally other liquids. Now, half of the volume of soil is made of actually only solid material. So only about half of soil is solid. The rest of it's either liquid or gases. Okay, in the soil, waters and gases fill small holes at what we call pores. And what happens, this allows water to flow underground. And water can flow through these pores. Now, the movement of water through pores, this is kind of an important term, it's called porosity. Okay, which we'll get into in a minute. Sand is more porous than silt, which is more porous than clay, which when compacted clay is essentially has no porosity, or in other words, water can't pass through it. So let's get into this. Now, the solid part of soil, once part of living organisms, of course, is organic material, or the organic matter, so we just talked about. This is when, if you remember from last year in life science, once living material undergoes decomposition by organisms in the soil, detrivores will eat it, they'll break it down, pass it on, poop it out, things like that. Or it rots without anything eating it apart from bacteria. Organic matter will help hold water and nutrients in the soil. And usually the more organic matter in the soil, the more nutritious the soil is for plant growth. Now, the inorganic parts of rocks are made from materials such as rock fragments that have never been alive. Of course, inorganic means it's not organic. Organic meaning having carbon-based molecules in it. So sediments, remember, are made of minerals which are inorganic. So that's the big difference between the two, is that soil includes organic matter, whereas sediments do not. Okay, so your textbook mentions in a little square about sand, silt, and clay. But I wanted to talk about it because it's important where we live in Louisiana, South Louisiana. Now, when we were talking about rocks, you're all bored to tears and couldn't understand it because it's the only rocks you ever really see are at the railroad tracks or in the concrete yard, mixing yard. But where we live over here in South Louisiana, soil is everywhere. In fact, in places, sediment goes about 40,000 feet deep. And this sediment ends up compacting over time in a sedimentary rock. Okay, but you can look at, especially in areas off the Tesh Ridge, where it's really, really recent geologically. We're only talking about less than 10,000-year-old sediment. We're looking at sediment. We're talking about dirt that goes 70, 80 feet deep before you start hitting anything resembling rock. Okay, so there are 3 types of soil particles. Okay. First off is sand. Anything made with rough-grained mineral particles is sand. Whenever you rub sand together, it feels rough. Okay, if you pick up a piece of dirt and you rub it in your hands until it becomes nice and loose and stuff. If it feels rough to the touch, it's generally sand. Silt is medium grain mineral particles usually transported by water. The ground that we're on in South Louisiana, if you're here in St. Mary Parish, apart from the Teche Ridge, is silt. Okay, its river silt has been carried by the Mississippi River over time. The Teche Ridge, however, is clay particles. Okay, if you notice, before I go on to clay, you can actually see the particles in that silt and that on that person's finger. So it's a little bit bigger than clay, but it's a lot smaller than sand. But you can actually see the particles. Usually, it's really, really fine grains of particles, usually mica and things like that, whereas sand's usually quartz. Finally, we have clay. Clay is fine grain aluminum-based mineral particles. It's nearly impermeable to water when compacted. It's the finest. It's the finest grain mineral soil type. Okay, it's very, very loose and sticky whenever you rub it with your hands. Clay, as in pottery, that's what it's made from. And so what happens is it's made from aluminum-based mineral particles, and when you compact these super fine grain particles together, they form a layer that's impermeable to water, and water can't go through. In fact, in western Louisiana, crawfish ponds are really popular because of the clay down underneath the topsoil layer, because that clay is compacted to the point where you can pour water in and it'll hold water. That's also why rice is grown out in western Louisiana. We can't grow rice in eastern Louisiana or in this area in South Louisiana off of outside of swamp areas, because simply the ground won't hold the water. Okay, because it's got silt. The grains are much larger. As a result, there's bigger gaps between the grains, and the water just passes right through. So that's the difference. Remember, sand is rough, silt is smooth, clay is sticky. Okay, that's the three types of main soil types. Now, how is soil formed? Well, there's 5 factors, okay? And the main one I want to focus on is its starting materials, its parent material, okay? The actual rocks and stuff that it's made from. Down in South Louisiana, where we're at, the alluvium, the silt, comes from all over the western and eastern United States, and it's usually sedimentary and occasion igneous rocks. Now, parent material is made of the rock or sediment that weathers and forms soil. Okay, the particle size of and type of parent material can determine the properties of the soil that develops. Igneous rocks might have more quartz in it, more sedimentary mudstone, stuff like that, worn down over time. Clay material will determine those things like that. Okay. Also, number 2 would be the climate of the area. Okay, soil can form rapidly in warm, wet climates because there's a lot of water there. And because there's a lot of water, you'll have a lot of mechanical weathering being carried off by water, or even chemical weathering with chemical processes going on. The third type is the topography, or the shape or steepness of the landscape. Remember topographic maps. The closer the contour lines are, the steeper it is. Okay, areas that are flat will have more moist soil because water always runs downhill. If the gradient of the land is not very steep, water will take a long time to move. As a result, it gives water more of a chance to get actually into the ground. The fourth factor is the biota, or all the living organisms that live in the region. Some biota in the soil, like insects, moles, nutri-rats, things like that, form passages for water to move through and cause through weathering. Okay, and that also adds to the moisture content of the soil. The more biota there is, chances are the more fertile or the more nutritious the soil is. Finally, is time. As time passes, weather is constantly acting on rock and sediment. Soil formation is a constant but slow process. Okay, where we're at in St. Mary Parish, we're looking at land that's only about Teche Ridge is about 40,000 years old at the oldest. Marsh is much down south of Four Corners in Glencoe is far younger. We're only talking about a couple thousand years old. And around Sharonton and stuff in the Mississippi alluvial valley, we're looking at soil that's really at the oldest about 8,000 years old. Okay, and so that's actually That's actually a fairly mature soil, though. Mature soil will only be about undisturbed. In other words, nothing has been done to it for about 3 to 4 thousand years before it's considered mature. Okay, so let's talk about layers of soil, especially here in Louisiana, South Louisiana, where we don't have rock unless you go way far down. Okay, what we have are layers of soil. Okay, and the one that soil scientists call them, they call them horizons. Now, there are three common horizons common to most soils. Uh, and the example I'm going to give, and we're going to go back and forth looking at, they'll have a fourth one which is called the O horizon or organic. So let's start looking at that. Okay, the dead leaves and decayed material at the very top of the ground. Okay, leaves on top of the ground, things like that. That's your O horizon. That's your organic material. But below that, or the actual dirt itself, is the A horizon that we think of. The A horizon is the part of the soil you're most likely to see when you dig a shallow hole. It contains most of the organic matter in soil. Okay, and it's usually about 8 to 10 inches, or anywhere from 6 to 10 inches thick. When you go on a construction site, when we would go on a construction site, we would degrass, which what that does is it takes away that A horizon, the topsoil. It's a mixture of sediment and highly, highly organic material. Most of your organic material mixed up with your sediment is in your A horizon. Topsoil that you buy from Lowe's or Home Depot or Walmart or a garden store is A horizon soil. Now, once you get about anywhere from a couple inches all the way down to a foot, you then get into what we call subsoil or the B horizon. It usually contains clay particles, or here in Louisiana, when we start going deeper, you start changing the different types of silts you have. Now, the B horizon is generally, you'll see the difference between A and B in the color. It starts getting lighter in color. The reason why it's lighter in color is because there's lesser amounts of organic material. And usually outside of river valleys and stuff like that, you'll have more clay material in there, which it starts holding water. And because it holds water, that's why you'll often see roots of plants down there. Finally is your sea horizon. Okay, the sea horizon consists of parent material. Outside of river valleys, that's usually when you run into rock, the bedrock. Here in South Louisiana, that's where you have older silts that don't have a lot of organic material. But the important thing about the sea horizon has little to no usable organic material in it at all. Okay, so the highest amount of organic materials in the A horizon. Lesser amounts, but growing in clay usually will be your B horizon, and your C horizon is the bedrock or inorganic sediments there. Okay, so let's start wrapping things up and let's start talking about soil properties. Okay, the properties that a soil has determines its best use for the soil. Like I just talked about earlier, highly organic soil is oftentimes used for farming, but you can't farm same crops in same areas. For example, in western Louisiana where my parents live, they're in the middle of rice country. You can't grow sugarcane there. Conversely, you can't grow the rice that surrounds my parents' house on three sides here in St. Mary Parish. The properties of the soil, it doesn't work that way. Plants depend on the nutrients that come from organic matter and the weathering of rocks. The more nutrients in the soil, the more plant life it can sustain. That's why you don't see a lot of plants in the Sahara Desert, because the sand is not very suitable for life to grow on. Now, there are 9 properties of soil, okay? And there are 9 measurable ones. Let's look at them. Okay, first is color. Okay, the texture, the size of the individual soil particles. Remember, sand, silt, clay. The structure, whenever you dig up a soil and you start using a sieve or things like that, that allows you to filter particles. The way the soil clumps up is its structure. The consistency is its firmness or softness, usually related to water content. Dry soil is much more firm than mud, okay, because there's a lot more moisture in it. And speaking which, soil moisture at its normal, not after a rainfall or in the middle of a drought, soil moisture is usually the amount of water soil has. pH, or how acidic or basic a soil can be. Usually usually the pH of soil runs between a 6 and an 8. So it's just a little bit acidic, a little bit of basic. But with a lot of acid rain from chemical weathering, things like that, the pH might be pushed lower, which hurts or harms plant life. Also, the fertility, the ability to support plant life consistently. A lot of organic material there. And finally, the basal temperature, the base temperature of soil. The rate of change with air temperature. The lower into soil you go, the more slowly soil temperature will change as compared to air temperature. So, for example, when you dig down into the dirt, soil rather, down here in South Louisiana during the summer, you'll find that the soil is a lot cooler. And that's because it doesn't warm up as fast as the air or the soil on the surface. Okay, so that's the 9 properties that we look at, one of which is really important for plant life, of course, this is nutrients, but also the water consistency. Now, there isn't just one type of soil. We talked about several different types, and in fact, there are 12 broad categories of soil type, and it depends partly on the climate where you find it in, also what the parent material is, and which we'll look at right here. Okay, there's alpha soil, which is moderately weathered. Andesol comes from volcanic ash. Iridisol, usually sands in deserts, very dry. Entisol is newly formed. The marsh around Sycamore Point and places like that, or the delta being formed south of Morgan City and Wax Lake. That's entisol. Gelisol, we don't have that around here. It's frozen. That's up in northern Canada, places like that. Histosol is heavily organic or wet soil. You can usually find that in swamps. Inceptisol is young soil. Where we would be at, we would consider it a type of inceptisol in some places. Mollisols are deep and fertile soils, which you would sometimes find in the Great Plains, where there's a lot of farming stuff going on. Old and very weathered soils, which are oxosoils, those aren't really used for farming because there isn't a lot of organic material in them. Spodosoils are sandy and acidic. They don't support a lot of life. Or large life, and they're found in spots in Louisiana. Utilisoils, or ultisols rather, are moderately weathered. That's You'll see that out in East Texas and going out westward. And then you'll find vertisol, soil that moves a lot when it expands and shrinks when exposed to heat or moisture. So those are the 12 categories of soils. You don't need to know them, but your textbook mentions that there's 12 of them. Usually in Louisiana, we'll see inceptisoils, entosoils, and occasionally we'll find spodosoils, but we'll also find histosoils, and even in places around swamps, we'll not only find histosoils, but also vertisoils. So, by the end of this lesson, I know it's a bit long, but a lot of material and not a lot of pictures to go with it, but in class we'll do a demonstration. We'll actually look at some soil horizons. But how is soil created? Well, it's created through the combination of organic material that has been decomposed with weathered rock material in the form of sediment. It's a big mixture of organic solids, inorganic solids, gases, and liquids, mainly water. Now, soil horizons are the layers of soil that are divided by the amount of organic material in the layer. Your A horizon is your topsoil, your B horizon is your subsoil, and C horizon is usually your bedrock, or where we're at older sediment pushed down by the river. Finally, which soil properties can be observed and measured? There's 9 of them. Okay, color, texture, structure, consistency, infiltration, moisture content, pH, fertility, and temperature. And all of those can be used to classify the soils, of which there are 12 types on Earth. So, that's the end of this lesson. Hope you enjoyed it, tolerated it, stayed awake. But if you have any questions, feel free to ask them in class or put them on YouTube. And as always, thanks for watching.